welcome back. This is Unit 12, Day 2 notes. And today we're going to be taking a look at systems of equations by graphing, including special cases. So yesterday we did just graphing, and now we are looking at special cases included in that. Our intention today is that students will be able to solve systems of linear equations by solving for slope-intercept form, graphing, and identifying special cases with an 80% accuracy or higher. So let's get started. Some reminders from yesterday when graphing systems of linear equations. We want to solve for y, get into slope-intercept form, find that m, which is the slope, and the b, which is the y-intercept. Okay, so on to our first of three special cases. We have possibility number one. If we solve, or if we're given two linear equations, and there is one solution when this happens. This occurs when the equations have different slopes. So everything else, the only thing we can focus on or need to focus on is that the fact that they have different slopes. Let's take a look at this example. We have 2x plus 4y equals 12. We're going to go ahead and solve this for y to get into slope-intercept form. We get 4y equals negative 2x plus 12, and then reminder, we divide everything by that coefficient of 4, and we get negative 1/2, which is it's negative 2 over 4, but we're simplifying to negative 1/2 x plus 3. Our slope, negative 1/2, and our y-intercept is 0, 3. So let's go ahead and graph this one first. So we go over 0, up 3. A slope of negative 1/2 means down 1, right 2. And just like we did yesterday, we're going to graph and plot several points along this line because we aren't sure exactly where that second line is going to intersect. So the more points we put on now, the more likely that we're going to have that intersection happen at a nice spot when we graph it later. Okay. So there's our first line. Now let's go ahead and solve our second, which is 3x minus 2y equals negative 14. We subtract 3x from both sides. Negative 2y equals negative 3x minus 14. Divide everything by negative 2. Y equals 3 over 2, positive 3 over 2, x plus 7, so our slope, positive 3 over 2. Our y-intercept is 0, 7. So we're going to go over 0 up to 7. And then our slope, up 3 to the right 2. So we know, so we go up 3 to the right 2. We can graph that, but it doesn't show us any intersection because our first line was the other direction. So we're going to go and graph the opposite, which is down 3, left 2. We see that's where the intersection happens. Good thing we graphed some extra points. Let's go ahead and finish off our drawing here with a straight line using our straight edge. And this is our solution, which is negative 2, 4. Now, what we talked about, this is possibility number one. These are the possibilities that we looked at yesterday. So this is kind of like a recap. You're going to get one solution if the two lines have different slopes. So that's it, right? If we look at both of these examples, we have negative 1/2 and positive 3 over 2, different slopes. That's what we said needed to happen for one solution to occur. So that's situation number one. Situation number two. So there are no solutions in this situation. No solutions. This occurs when the equations have the same slope emphasize same slope, but different, you guessed it, y-intercepts. So when this happens, you see two equations, same slope, different y-intercepts. There's going to be no solutions. And this is why. Well, let's graph it first, and then we'll say why. But maybe you know why. Maybe if you think about this, right, we talk about a solution being where the two lines intersect. So that would be one solution. If the lines don't intersect, that's because we have no solutions. So probably should have prefaced that with a spoiler alert. But I didn't give you the exact terminology, which we will talk about in a second. So we finish solving. This is -1/3 x plus 4. So our slope is -1/3. Our y-intercept is 0, 4. Let's solve the second. Subtract 2x. Divide everything by 6. We get y equals -1/3 x plus 1. So as you see, we have the same slope, but different y-intercepts. So let me fix that. All right, so let's graph and see what this looks like. We have 0, 4, down 1 to the right 3, down 1 to the right 3. We'll go up 1 to the left 3. I think that's good enough. Let's go ahead and connect. Again, you only need 2. You only need 2 points to graph a straight line. So there's graph number 1. Now we go over 0, up 1. And we have the same slope, down 1, right 3. So we have the same slope. We're going to keep following that same pattern, and they will never intersect. What kind of lines are these? Well, we call these parallel lines. So the graphed lines are parallel, which is true, right? If two lines have the same slope, they will never intersect because they are parallel to each other. So parallel lines never intersect. Now, what we do want to say is that there is no solution for this. Because, again, the lines do not cross. All right, down to our last situation, 3 of 3. There are many solutions for this. This occurs when the equations are the exact same. -3x plus y equals -4. Add 3x to both sides. We get 3x minus 4. That one's done. Y is now by itself. Slope 3, y-intercept 0, -4. -6x plus 2y equals -8. Add 6x to both sides. We get 6x minus 8, and then we divide everything by 2. And after solving this, we see that we have the exact same line or equation for both. Y equals 3x minus 4 and y equals 3x minus 4. Therefore, the slopes are the same and the y-intercepts are the same. If they are exactly the same, they're going to be graphed on top of each other, which means every single point is an intersecting point because they share everything because they are the exact same line. So up 1, 2, 3 over 1. Because we know this, 2 points should be fine. 2 points to graph a straight line. That's all you need. And there we have it. So I'm just going to emphasize this point by, right, I always kind of circle when they have those intersection points. So we can say lines share every point. And that's why it's infinitely many solutions. no matter what point you pick. They're the same line, so they share 'em. Okay, that's it for today. A lot shorter today than it was yesterday. Great job. Make sure you reach out to your teacher if you have any questions. Other than that, we'll see you in the next set of notes. Have a great rest of your day. Peace out.